Good morning students, Saira. Welcome back to the Maths online classes. Let's continue with chapter 7, fractions. Let's have a quick recap of what we have learnt in fractions. Children, what is a fraction? A fraction is a number that represents a part of a whole. The whole may be a single object or a group of objects which is divided into equal parts. Fractions can be represented using numbers, figures or words. Here we have shown a few fractions. First one, it represents half of the whole, 1 upon 2. Second one, the shaded part is 1/4. Third one is 1/3, 1 upon 3. And the last one is 3/4 or 3 upon 4. The shaded part is 3 upon 4 of the whole. What are proper fractions? When numerator of the fraction is less than the denominator, then it is called a proper fraction. We have an example here, 3 upon 5. And what is an improper fraction? When numerator is greater than denominator, then the fraction is improper fraction. For example, 20 upon 3. And what are mixed fractions? Mixed fractions are a combination of whole and a part. Improper fractions can be represented as mixed fraction. The quotient becomes the whole and the remainder upon divisor is the part. So mixed fraction is equal to quotient remainder upon divisor. So the improper fraction 20 upon 3 can be represented as 6 2 upon 3. 6 is the whole part and 2 upon 3 is the fractional part. So this is a mixed fraction. Now coming to the next topic. What are equivalent fractions? Children, look at these pictures carefully. In the first figure, we have half of the figure is divided into two equal parts and only the one part of the figure is shaded, which represents 1 out of 2 or 1 upon 2. In the second one, the whole is divided into 4 and two parts are shaded. So the fraction is 2 upon 4. And in third one, the figure is divided into 8 equal parts and 4 are shaded. So the fraction is 4 upon 8. Children, the fractions 1 upon 2, 2 upon 4 and 4 upon 8, they may look different but they are equal fractions. They represent same part of the whole. So the fractions which have same value even though they may look different are called equivalent fractions. In other words, the equivalent fractions, they represent same part of the whole. So 1 upon 2, 2 upon 4 and 4 upon 8, they represent 4 upon 8 they represent the same fraction of the whole and they are called equivalent fractions. Now how do we have a few more examples of equivalent fractions here, like 4 upon 8. 4 upon 8 is equal to 1 upon 2. 4 upon 8 represents half of the figure as is 1 upon 2. So 1 upon 2 and 4 upon 8 are equivalent fractions. Similarly, 3 upon 4 and 6 upon 8, they represent same part of the whole. So they are equivalent fraction. Similarly, 2 upon 3 is equivalent to 6 upon 9. 4 upon 12 is equivalent to 2 upon 6 and 1 upon 5 is equivalent to 2 upon 10. Now how do we find the equivalent fraction of a given fraction? To find an equivalent fraction of the given fraction, we multiply or divide the numerator and the denominator of the fraction by same number. So what is the first method? The first method to get an equivalent fraction of a given fraction is by multiplying both the numerator and the denominator by the same number. For example, if we have a fraction 1 upon 3, so to get its equivalent fraction, we multiply the numerator 1 by 2 and also the denominator 3 by 2. And what do we get? We get 2 upon 6. So 2 upon 6 is equivalent fraction of 1 upon 3. Similarly, we can get more equivalent fractions of 1 upon 3 by multiplying both the numerator and the denominator by the same number. Like we have shown here, we have multiplied both the numerator and denominator by 3, and what do we get? We get 3 upon 9. So 3 upon 9 is another equivalent fraction of 1 upon 3. Similarly, if we multiply both the numerator and denominator by 4, we get 4 upon 12, which is another equivalent fraction of 1 upon 3. So this way, by multiplying both the numerator and denominator by the same number, we can get the equivalent fraction of the given fraction. Second method is, to get the equivalent fraction of a given fraction, we can divide both the numerator and the denominator by the same number. For example, if we have an equivalent fraction like 12 upon 15. So to get its equivalent fraction, we can divide its numerator and the denominator by the same number. We have divided both the numerator and the denominator by 3, and what do we get? We get 4 upon 5. So 4 upon 5 is the equivalent fraction of 12 upon 15. Let's look at one more example. Find the equivalent fraction of 2 upon 5 with numerator 6. So here we have a fraction 2 upon 5. So how do we get the numerator 6 here? We get the numerator 6 by multiplying the numerator 2 by 3, isn't it? That means we have to multiply both the numerator and denominator by 3 to get an equivalent fraction which has the numerator 6. So here we have done both the numerator and the denominator have been multiplied by 3, and what do we get? We get 6 upon 15. So 6 upon 15 is the required equivalent fraction. Here we have more examples. Find 3 equivalent fractions of 1 upon 2. How do we get? We can multiply both the numerator and the denominator of 1 upon 2 by different numbers, and we can get their equivalent fraction. Here in the first example, 1 and 2, both the numerator and denominator have been multiplied by 2, and we get 2 upon 4. Similarly, if we multiply both the numerator and denominator by 3 here, so what do we get? We get 3 upon 6. If we multiply both the numerator and denominator by 4, what do we get? We get 4 upon 8. So these are the equivalent fractions of 1 upon 2. 2 upon 4, 3 upon 6 and 4 upon 8 are the equivalent fractions of 1 upon 2. Now one more example here. Find the equivalent fraction of 18 upon 27 with denominator 9. So how do we get a denominator 9 in this case? If we divide the denominator 27 by 3, we get the denominator 9. So that means we have to divide the numerator and denominator of this fraction by 3. So what do we get? If we divide the numerator 18 by 3, we get 6, and the denominator, when we divide 3, we get 9. So 6 upon 9 is the fraction which we are getting. So the equivalent fraction of 18 upon 27 with denominator 9 is 6 upon 9. So this is how we get the equivalent fractions of a given fraction. Now what is the simplest form of a fraction and how to get it, how to find it? A fraction is said to be in its simplest form or lowest form when if its numerator and denominator have no common factor except 1. So how do we get it? We get it by finding the HCF of the numerator and denominator and then dividing both of them by the HCF. So to find the equivalent fraction, which is in simplest form, we have to find the HCF of the numerator and denominator and then divide both of them by the HCF. Let's understand this by taking this example. So what will be the simplest form of the fraction 36 upon 24? We find that it is 3 upon 2. How do we get it? The HCF of 36 and 24 is 12. So if we divide both the numerator and the denominator by 12, we get 3 upon 2. So 3 upon 2 is the simplest form or the lowest equivalent fraction of the fraction 36 upon 24. One more interesting fact about the equivalent fractions is the cross product of two equivalent fractions are always equal. Let's see how. Here we have two fractions 1 upon 3 and 3 upon 9. Are they equivalent? To find this, we have to cross multiply the denominator and the numerator and denominator of the two fractions. So first we multiply 1 and 9 and we get 9. Then we multiply 3 into 3, this is cross multiplication, and we get 9. So the cross product of two fractions are equal. So these two fractions are called equivalent fractions. Similarly, in the second example, if we cross multiply 4 and 35, we get 140. And if we cross multiply 28 and 5, we get 140. So we can find that both the cross products are equal. That means both the fractions are equal. They are equivalent. Let's find out in the next example whether the fractions are equivalent or not. If we multiply 1 and 16, if we cross multiply 1 and 16, what do we get? We get 16, isn't it? And if we cross multiply 4 and 4, what do we get? 4 multiplied by 4, we get 60. So in both the cases, the cross products are 16. So the two fractions are called equivalent fractions. In the next example, the two fractions are 2 upon 3 and 10 upon 15. So we multiply 2 and 15 and 10 and 3. So if we multiply 2 and 15, what do we get? We get 30. And if we multiply 10 and 3, what do we get? We again get 30, which means both the fractions are equivalent fractions. So this method helps us to find whether two fractions are equivalent or not. Based on these learnings, let's start solving the problems of exercise 7.3. Here we have a pictorial representation of fractions. We have to write the fractions for them and decide whether all the fractions are equivalent. So if we see the first figure, here how the picture, the whole is divided into two equal parts and one part is shaded. So the fraction is 1 upon 2. In the next one, the whole is divided into 4 equal parts and 2 parts are shaded. That means it is 2 upon 4, which is equal to 1 upon 2. In the third one, here we have 3 parts out of the whole, out of the 6 parts, shaded. So the fraction is 3 upon 6 and the fraction will be 1 upon 2 in its lowest form, and in the last one 4 are shaded out of 8. So again it is 4 upon 8, that means it is 1 upon 2. That means all these fractions are equivalent. Here in the first figure, 4 out of 12 balls are shaded. So the fraction is 4 upon 12, means it is 1 upon 3. In the next one, 3 are shaded out of 9. 3 upon 9 is the fraction. Again it is 1 upon 3. In the third one, here 2 out of 6 are shaded, 2 upon 6, and the fraction in lowest form will be 1 upon 3. Here we can see the picture that 1 is shaded out of 3, so the fraction is 1 upon 3. And in the last one, it is 6 out of 15, that means 6 upon 15, and the fraction is 2 upon 5 in the lowest term. So all the fractions here are not equal, they are not equivalent. They do not represent same part of the whole. Now in this question, we have to write the fractions and pair up the equivalent fraction from each row. Let's find out the fractions of the figures, given figures. In the first one, A, it is 1 upon 2. In B, 4 out of 6 are shaded, so it is 4 upon 6, that means it is 2 upon 3. Then in third one, it is 3 upon 9. 3 out of 9 are shaded, and in the lowest form it is 1 upon 3. Then in this one, fourth one, D, 2 upon 8. 2 out of 8 are shaded, that means 2 upon 8. And what will be its lowest form, lowest equivalent term? It will be 1 upon 4. And in the last one, E, it is 3 out of 4, that means 3 upon 4. Now let's find out the fractions in the lower row. Here in this one, 6 out of 18 shaded, that means 6 upon 18, which is equal to 1 upon 3. Here we have in the second one, 4 out of 8, 4 upon 8, which is equal to half or 1 upon 2. And 12 upon 16 is equal to 3 upon 4. Then 8 out of 12 shaded means 8 upon 12, which is equal to 2 upon 3. And last one, 4 out of 16 shaded, 4 upon 16 is equal to 1 upon 4. Now let's match them. First one, A, 1 upon 2 is this one, equivalent to this one. Second one, then 2 upon 3, this one is equal to this one, 8 upon 12. Then third one, C, 3 upon 9 is equal to 1 upon 3 is equivalent to 6 upon 18. Then this one, D, 2 upon 8, which is equal to 1 upon 4, will be equal to the last one, 4 upon 16. And E, 3 upon 4 is equivalent to the third figure, 3 upon 4 or 12 upon 16. Moving on to the next question. Replace the box in each of the following by the correct number. Here we have two fractions, one blank is given. So 2 upon 7 is equal to 8 upon dash. So we have to find the equivalent fraction of 2 upon 7 such that the numerator is 8. We can understand we will get the numerator 8 by multiplying 2 by 4. That means we have to multiply both the numerator and the denominator here by 4. So here we have done this. If we multiply both the numerator and denominator by 4, what do we get? We get 8 upon 28. So 8 upon 28 is the equivalent fraction of 2 upon 7. So the box will be filled by 28. Next question, 5 upon 8 is equivalent to 10 upon dash. So if we observe here again, how do we get 10 as numerator? We multiply 5 by 2 and then we get 10. That means we have to multiply this fraction by 2. Both the numerator and the denominator have to be multiplied by 2. If we multiply them by 2, what do we get? We get 10 upon 16. So the box will be filled by the number 16. So 10 upon 16 is the equivalent fraction of 5 upon 8. Next problem, D, 45 upon 16 is equal to 15 upon dash. So if we see look at the numerator, we can see that we get the numerator 15 by dividing 45 by 3, isn't it? So we have to divide both the numerator and the denominator of the fraction by 3. So if we divide both the numerator and denominator by 3, what do we get? We get 15 upon 20. 15 upon 20 is the equivalent fraction of 45 upon 60, which has the numerator as 15. So the blank will be filled by the number 20. Coming to question number 4. Find the equivalent fraction of 3 upon 5 having denominator 20. So here we have a condition, we have to find the equivalent fraction of 3 upon 5, but the denominator should be 20. How do we get denominator 20 here? If we multiply 5 by 4, we get the denominator 20. That means we have to multiply this fraction 3 upon 5 by 4. The numerator and the denominator both have to be multiplied by 4. So if we multiply both the numerator and denominator by 4, what do we get? We get 12 upon 20. So the box will be filled by 12. 12 is upon 20 is the equivalent fraction of 3 upon 5 with denominator 20. Next question, find the equivalent fraction of 3 upon 5 having numerator 9. Here we have to find equivalent fraction of 3 upon 5 such that the numerator is 9. How do we get numerator 9? We get numerator 9 by multiplying 3 by 3, isn't it? So how do we get 9? We get by multiplying 3 by 3. That means we have to multiply this fraction, the numerator and denominator of this fraction by 3. So here we have shown this. If you multiply both the numerator and denominator by 3, what do we get? We get the fraction 9 upon 15. So 9 upon 15 is the equivalent fraction of 3 upon 5 with the numerator 9. So the box will be filled by the number 15. Moving on to the next problem. Find equivalent fraction of 36 upon 48 with numerator 9. So how do we get numerator 9? We get it by dividing 36 by 4, isn't it? That means we have to divide the numerator and denominator of this fraction by 4. We have done this here. What do we get? We get 9 upon 12. So 9 upon 12 is the equivalent fraction of 36 upon 48 with numerator 9. So the box will be filled by the number 12. Next problem. Find the equivalent fraction of 36 upon 48 with denominator 4. So we have to find the equivalent fraction of 36 upon 48 such that the denominator is 4. How do we get denominator 4 here? We get the denominator 4 by dividing the number 48 by 12, isn't it? That means we have to divide both the numerator and denominator of this fraction by 12. We have done this here. So what do we get? We get 3 upon 4. So 3 upon 4 is the equivalent fraction of 36 upon 48 by with denominator 4. So the box will be filled by the number 3. Children, with this problem I end this session. We will solve more problems of this exercise and learn more topics in our coming session. Thank you.